Let's take a look at problem number 7. Absolute value inequalities. So absolute value inequalities. This semester in one of my classes, I'd write some stuff up on the board like I'm doing right now, and sometimes I'd type in the Word, and they would see what I'm typing in the Word. I asked them today which one they prefer, and they actually said they prefer when I handwrite it. As weird as that seems. So my writing's not that great, as you can tell. Okay, case 1. We got the absolute value of something is less than something else. Now if it's in this form, then you can rewrite it using this formula. Now case 2 is where you have the absolute value of something is greater than something else. If you have it in that form, then you can rewrite it as P is less than negative Q, or P is greater than Q. Now that or does not mean you can choose one or the other. You have to plug it in this entire formula. Now in books you'll never see where they give the other formula. If this is less than, you got a problem that's less than or equal to, and you have a line underneath here, it's assumed that you just draw a line underneath all of these inequality symbols. So that's the only change. So let's look at number 7. We got absolute value of 5x plus 4 is less than 5. Now the absolute value has to be on the left side, and it has to be by itself. We can't have any numbers in front of it, any numbers after it. Well, in this particular problem, the absolute value is on the left side, and there's no numbers in front of it, and no numbers after it. Now, if I look at this, it has a less than, which matches case 1. Now, what's inside the absolute value is our P, and the other side is our Q. And our formula is negative Q is less than P is less than Q. So everywhere we have a Q, we'll put in 5, and everywhere we have a P, we'll put in 5x plus 4. So we got negative 5 is less than 5x plus 4 is less than positive 5. Now at this point, this is a compound inequality with 3 sides. And if I write down my steps for that, let's see, solving compound inequalities with 3 sides. Now it's kind of implied that no matter where you are, if you have like terms, numbers, go ahead and combine them together. So that's assumed. First step, get rid of parentheses. And you do this via the distributive property. Step 2, get rid of fractions. Multiply everything by the LCM of all the denominators. Step 3, get everything with an x in the middle. Numbers on the other 2 sides. Step 4, divide all 3 sides by the number in front of the x. And we have a note that says if you multiply or divide all 3 sides by a negative number, flip the inequality symbol. So let's use this to solve this. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x in the middle, numbers on the other 2 sides. Well, we're going to take this 4, but instead of moving it just to the other side now, we're going to move it over to the other 2 sides. Now when you take anything across your inequality symbol, the sign changes, so it becomes a negative 4. Combine the numbers at any step. Negative 5, negative 4 is negative 9. 5 minus 4 is 1. Fourth step, divide all 3 sides by a number in front of the x. Well, the number in front of our x is a 5, so we're going to divide all 3 sides by 5. 5's would cancel there. And we get negative 9/5 less than x less than 1/5. Now let's see what kind of format they want it in. Interval notation, set builder. Set builder is easy. You put curly brackets around all of it. Put the variable we're dealing with, x, with a vertical bar, and then you put the rest down. This is a set of all x values such that this is true. So x negative 9/5 less than x less than 1/5. Looks like A is our answer. So 7A. And that checks.